All right, we're going to go ahead and get started with section 2.3, which is all about approximating these trig functions. So we are going to use our calculator. So you are going to need your calculator for this section. This is the calculator I'm going to demonstrate on. Yours should be similar, okay? Remember, you cannot use a graphing calculator for this section. You can use any kind of scientific calculator, which looks pretty similar to this without graphing, capabilities. What you're looking for is to make sure you have a sine, cosine, and tangent button, and that you have the second functions here, which are the inverse sine, inverse cosine, inverse tangent buttons as well, okay? The other button you need to locate is this one that has the degree, minutes, seconds button, okay? So if you can't see on this, I'm going to go ahead and say there's a button, or it may be a second function that has the degree, the minutes, and the seconds function, okay? And you also want that second function, which most of them it's on a second function, for those inverse trig functions, okay? So I'm just going to go through a few examples, make sure we're comfortable using our calculator, and then we'll get into how we're going to use this to actually solve some of these, okay? So I'm going to do this one first. I'm going to do them a little out of order on purpose. So I'm going to do this one first. I'm going to do this one second. I'm going to do this one third. And then I'm going to let y'all do this one as a practice problem, okay, in part C. So let's look at our first one here, part B. It says cosine of 193.622 degrees. Now, we want to make sure that our calculator is set in degrees. So if you're using a calculator like mine, you can see there's a button here that says DRG. That stands for degrees. And if you push that button, that's where you can change it from like degrees to radian. So just make sure it's in the degree mode for now, okay? And then we type it in just like it looks. Cosine, it's going to open our parentheses for us. We do 193.622, and we put in that little degree symbol. And it tells us that this is approximately, I'm going to scoot this over, negative 0.97187, blah, blah, blah. It keeps going, right? Notice here, it doesn't tell us what we're going to be rounding to, but more often than not, we usually keep about 3 decimal places. Sometimes we only keep 2, it just depends. But more often than not, we keep about 3 decimal places. So that's what I'm going to round to. So if we round to 3 decimal places, 1, 2, 3, then that puts us at the 1. Notice there's an 8 behind it. So I'm going to say this is approximately negative 0.972. All right. Same idea on part D, which I'm going to do second. Now notice this is secant. And if we look at our calculator, we don't have a secant button, right? So we're going to use what we know of our trig functions and how they're related and those inverse identities to be able to simplify this. So we know that secant is the inverse of cosine, right? So I could rewrite this as 1 over the cosine of negative 287 degrees, right? Now this whole thing, your calculator should be able to do this in one step. If you're using a little bit more of a basic calculator, you may have to calculate this bottom value and then do 1 divided by it, but it should allow you to do this all in one step. So let's see if that's the case for me. So I'm going to do 1 divided by. Now, because we're dividing by this whole thing that's in the denominator here, I'm going to use parentheses around everything that goes in the bottom. So cosine, and then notice it opens another set of parentheses so I can say what we're actually evaluating, negative 287 degrees. And then I'm going to close my parentheses that says that's all we're taking the cosine of, and then I'm going to close the parentheses that say that's the whole denominator. Okay. And this tells me that this equals 3.4203 and some more stuff, right? Now, if your calculator didn't let you do that all in one step, what I would suggest is go ahead and get a decimal value for this denominator and then do 1 divided by, whatever the last answer was on your calculator, okay? Again, I'm going to go ahead and just round it to the third decimal place. So if we round to the third decimal place, it's a 0, there's a 3 behind it, so it's not going to move up any. So we're going to say this is approximately 3.420. Okay. And it's important if they tell you to round to however many decimal places that you actually include that 0, because that lets us know that's the measurement we're cutting it off at. Okay. I know a lot of times if we say let's round to 3 decimal places and it ends up being a 0, we just drop it and write 3.42. But we're going to learn in the next section how important it is to keep all of our significant digits. So if it says to round to 3 decimal places, we want to make sure our answer, reflects that. Okay. All right, let's look at this next one. This one says tangent of 64 degrees, 43 minutes. Now, you could go ahead and change this all into degrees. You could get this in decimal degrees, but your calculator should be able to do it without having to convert. So again, we're going to go ahead and just find our tangent button. And when it opens up parentheses, we do 68. We're going to use that button that shows where the degrees are. Okay, we're going to select degree and then type in 43 minutes. And we're going to hit that degree button again, but this time I'm going to go over and select minutes. Okay, and then close your parenthesis once you have finished typing in everything you're taking the tangent of. And this comes out to 2.5670, 2.56707 and some more stuff, right? Okay, and then again, we're going to go ahead and just round to 3 decimal places. My third decimal place would be the 7. Since there's a 0 behind it, it doesn't go up in value. So this is going to be approximately 2.567. Okay. Now, again, I'm rounding these to 3 decimal places, but in your My Math Lab homework, it will tell you exactly what decimal place to round it to. So make sure you pay attention. It may want 2 decimal places. It may want 5 decimal places. So just do it according to your specific problem. Okay? All right, so go ahead and pause the video. I'm going to have you try this one. And then whenever you're ready, play the video again and we'll see how you did. Okay? Okay, so let's go ahead and see how you did. Notice here we have cosecant. Cosecant is the inverse of sine. So before we can do this in our calculator, we first have to write it in terms of sine so that we can use our sine button on the calculator, right? So this is the same as 1 over sine of 35.8471 degrees. And then again, this is a step we should be able to do in our calculator. If you have to do top and bottom separately and then divide, that's fine. Either way, you should get 1.7075, and we are rounding to 3 decimal places. So we should have got 1.708. Okay? So hopefully not too bad. What I want to introduce next is our inverse trig functions. Okay? And this is basically having us think about our trig functions in a backwards kind of way. So I'm going to explain what this notation looks like, or what it actually represents, and then how we can find that. So what this is saying is the sine inverse of 0.9677091705. What we're looking for is we want to know what angle this is. Okay, so notice on the other ones we were given a degree measure and we were finding the trig value. What this is doing is it's telling us the trig value that we got using sine, and we're trying to figure out what angle would we have to take the sine of to end up with this value. Or in other words, this means that sine theta is equal to 0.967709 1705. Okay, so if we took the sine and evaluated the sine of this theta angle, we know what that sine value is. So we're kind of working it backwards. We're trying to figure out, if we're given the sine value, can we figure out what the original angle is? Okay, so really we're solving for theta. Okay, now notice, if I wanted to get theta by itself here, I would need to get rid of this sine, right? So the way to get rid of a sine is to do the sine inverse. Now, I'm not going to have you write this out because you can do it in your calculator. I just want to explain where it's coming from. So it's kind of like we're taking the sine inverse of both sides. So notice over here, my sine and sine inverse will cancel out, and I'll just be left with theta is equal to sine inverse of this. Okay, so again, I'm just showing you where this notation comes from. 0.91705. Okay, but in order to solve this, we're going to plug it into our calculator, just like you would assume. We're going to use that inverse sine button. So on my calculator, it's the second function on the sine key. So I'm going to hit my second function button and then sine, which shows the sine inverse, and then I'm just going to type in the number they gave me, which is 0.96770911705, and hit enter. And notice it gives me 75.4. Okay, and again, we're still in degrees. So the angle that we evaluated the sine function on was 75.4. Okay, and then you can actually check yourself easily. If you just take the sine of 75.4, it should give you this decimal back, and then you know you did it correctly. Okay. All right, so same idea. I would like y'all to try these two, B and C, as practice problems. Okay, so go ahead and pause the video and give those a try, and then whenever you're ready, we'll go over them. Okay. All right, so let's see how you did. On the first one, I went ahead and rewrote it because I like to always put a theta angle here so that I know anytime I see that inverse, I'm solving for the angle, not for an actual trig function value. Okay, so what angle gave me this cosine value? When you type it in, you should have got 14.6. Make sure you put that degree symbol there so that we know that we're talking in degrees. Okay. All right, and then for part C, same idea. I always put theta, so I know I'm looking for an angle measure. I'm looking for what angle gave me a tangent value of 0.967, blah, 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 right? And when I put this into my calculator, this one didn't come out pretty. So the way that I decided to round this to one decimal place is because on part A and part B, they came out to one decimal place answers, right? So I went ahead and just rounded to the nearest tenth on part C, which gives me 44.1 degrees. Okay. All right, so now we're going to use the same idea to help us solve. Here, it just gave it to us, and all we had to do was plug it into our calculator. On the next page, we might actually have to do one or two steps to isolate the angle that we're solving for. So let me show you what we're talking about here. All right, so here, I just want to highlight again, when we talk about inverses, inverses undo one another, okay? Inverses undo one another. So when you see cosine inverse or sine inverse, it does not mean that you're flipping it and making a reciprocal, okay? Sine inverse of theta does not equal 1 over sine theta, okay? This is a big misconception. Sorry, let me scoot this down so you can see it. This is a big misconception, okay? This inverse, that's inverse notation. It does not mean it's sine to the -1 power, okay? So, no, don't do that, okay? Inverses undo one another, meaning if I evaluate sine inverse of sine theta, that just gives me theta, okay? It would be the other way also. If I evaluated sine of sine inverse that would just give me theta, because a trig function and its inverse cancel each other out. And this is true for all of them, right? We could do this for cosine inverse of cosine theta, and those would cancel out and leave me with just theta. Okay, I'm not going to write out every possible one, but basically what we need to know is that inverses undo one another, right? The inverse undoes that specific trig function. So here it says, use a calculator to find an acute angle that satisfies this. Okay, so we are finding an acute angle. So that means we're solving for theta. We're trying to figure out what that angle is. So here I need to get my theta angle on one side all by itself. And the only way I can do that is to get rid of this cosine. So the way that we get rid of cosine is we use cosine inverse. So I'm going to do cosine inverse of the left-hand side and cosine inverse of the right-hand side, right? So whatever we do on one side, we have to do on the other. So that way my cosine and my cosine inverse will cancel over here on the left, and I'll be left with theta is equal to cosine inverse of 0.9211854056. Okay, and now this is something we should be able to plug into our calculator, right? Using that inverse function, second function on our calculator. Okay, so we're going to use our second function to get the inverse of cosine, and then 0.9211854056 is what we're evaluating it at. And notice what we end up with is 22.89999999, right? So 22.89999999, right? And on these, I'm going to go ahead and just round them to one decimal place because that's what we did on the other page. My math lab will give you specific instructions on how to round. So we're just going to say this means that theta is approximately 22.9 degrees. Okay? Maybe not too bad. Okay. All right, let me look at another one. Cotangent. Now, cotangent is an a reciprocal identity, right? So we don't have a cotangent button on our calculator. So I first need to write this as tangent, and then I can go ahead and solve. So remember, cotangent theta is the same as 1 over tangent theta, right? So if I wanted to write this as tangent theta, I have to do the reciprocal. So that would give me 1 over 1.4466474, right? And then, remember, I'm solving for the actual angle, right? Which means I need to get rid of this tangent. The way to get rid of tangent is to do tangent inverse. If I do it on one side, I have to do it on both sides. So I'm going to do tangent inverse of this nasty fraction I just created, right? That way my tangent and tangent inverse will cancel, and I end up with theta is equal to tangent inverse of my big ugly fraction, right? 1.4466474. And now this is something I should be able to do in my calculator. Okay. So we're going to look for our tangent inverse button. And then this, we should be able to do just all in one step in here. So I'm going to do 1 divided by 1.4466474, close my parentheses, and notice we end up with 34.654 and some more stuff, right? And this is degrees. Now, make sure you're following along and trying this on your own calculator, because once you get to your homework, you know, if yours isn't working, I can't really help you troubleshoot that, right? So make sure you're working these through with your own calculator. Okay, again, if I round it to one decimal place, the 5 is going to bump that up to 34.7 degrees. Okay. All right, I want to show you one more, and then I'm actually going to give you a practice problem, and then we're going to quickly look at grade resistance and radar speed. Okay. All right, so just another example of using a calculator to evaluate. I just want to show you how to type these things in. Okay, so this wants us to evaluate cosine of 100 degrees, sine of 80, minus cosine of 80 degrees, minus sine of 100. Okay, you should be able to type this all in one step. And if you are in degree mode, you should not have to write, oops, I do parentheses because that's how it does it in the calculator. You shouldn't have to write the little degree symbol in there if your calculator is in degree mode, okay? No need to enter the degree thing if in degree mode, okay? The only time you absolutely have to use the degree or the seconds and the minutes is if you have degrees, seconds, and minutes, right? If you just type in 100 and you're in degree mode, it's going to assume that that's 100 degrees, okay? So cosine of 100, sine 80, minus cosine 80, sine 100. Okay? We should be able to just type it all in one step like that. Now, if you're not able to type it in all in one step, if you have a more basic calculator, you might have to calculate each of these individually and multiply them together. Okay, but hopefully if you have a good scientific calculator, we can do this all in one step. Let me see if I can get it to where you can see my calculator and my paper. All right, so we're going to go ahead and do cosine of 100, and then make sure once you enter that, you close the parentheses. Otherwise, it's going to think you're doing cosine of this whole mess. So close the parentheses after each one. And then sine of 80, close the parentheses, minus cosine 80, and, oops, I didn't need to put extra parentheses in there. Cosine 80, sine 100. Enter. And what we end up with is negative 0.342020143 and some more stuff, right? Again, they'll probably have you round it to 2 or 3 decimal places, and that will be outlined in your My Math Lab assignment. I'm going to go ahead and just round to 3 decimal places. So we're going to say this is approximately negative 0.342. Okay. So hopefully this hasn't been a horrible section so far, just learning to use your calculator to evaluate or get approximations for trig function values. So I want to give you one like this just to type in to make sure you get the same thing I do. Make sure your calculator's on point. So I want you to try cosine 70 degrees, sine 30 degrees, plus sine 70 degrees, cosine 30 degrees. Okay? So go ahead and pause the video, give that a whirl, and then we'll see how you did when you play the video again. Okay? Okay, so when we enter this into our calculator, we would just enter cosine 70. Make sure you close your parentheses. Sine 30 plus sine 70 cosine 30. Always closing your parentheses after you enter each of the values. So you should have gotten 0.9848 and some more junk. And remember, this is in, oops, I almost forgot, degrees. So make sure you enter, make sure you have that on your answer, okay? All right, so the next thing, or really the last 2 things I want to talk about, are some formulas we're going to use when solving application problems. And the first one is grade resistance. Now, just know, when I test you on this, I am not going to have you memorize these formulas. I will give it to you, okay? But you need to know how to use it. So when we talk about grade resistance, that is this formula right here, that it says that force is equal to W, which is the weight of the object, times sine theta. And this says, you must be wondering where that comes from. We're not going to worry about this. Okay, this is just a little example that I usually do if we have time. to derive this formula, but because this is being offered in an online setting this semester, this is not something I would ever have you derive. Okay, so really what I'm looking for is to make sure if I give you a grade resistance problem, you know how to use this. So either you're going to be given a force and an angle, and you're going to have to solve for W, or you're going to be given the weight and an angle, and you're going to have to find the force, or you're going to be given the force and the weight and have to find the angle. Okay, so you're just going to be using this formula, and you're going to be able to plug two things into it and solve for the one you don't know. Okay, so let's look at some examples. When we look at these down here, it says find F, so find the force for a 5,500 pound car traveling uphill grade with theta equaling 3.9 degrees. Okay, now anytime we see uphill, or down here you see downhill, that just tells us what kind of answer we should end up with, right? If we're dealing with an uphill grade, we should get a positive answer. If we're dealing with a downhill grade, we should get a negative answer. So I'm going to go ahead and just write down our formula, which is F is equal to W sine theta. And I'm just going to fill in what I know. It says find F, so we know we don't know F, okay, which is equal to W, that's our weight, so 5,500 times sine theta. And here our theta is 3.9 degrees. So this is something we should easily be able to punch into our calculator, right? So we're going to do 5,500, and you don't even have to put times. If you just write it next to sine, your calculator will know you're multiplying. And then 3.9, I'm not putting the degree in because I'm already in degree mode. I hit enter, and this gives me a force of 374.084 and some other stuff. Right? Okay. All right. Now, when we're talking about the force, usually we're talking, I think usually we're talking about it in pounds, but I don't think they'll have you enter that on my math lab, so I'm not going to worry about that. I am going to go ahead and round it though, and a lot of times we round it to the second decimal place. Again, just make sure that you check on your specific assignment in my math lab, okay? So this would give us approximately 374.08 as our force, okay, that we're dealing with. All right, let's look at another one. Same thing, okay? If you get the idea, you can kind of work ahead of me and then just check at the end. So our formula is force is equal to weight times sine theta. Here we're wanting to find F, so we don't know F. It says we have a 2,800 pound car traveling a downhill grade with sine equal to negative 4.8 degrees. So my weight is 2,800, and I'm calculating sine of negative 4.8 degrees. So again, I'm going to plug that into my calculator. 2,800 sine of negative 4.8 degrees. And that gives me a force of negative 234.2979 and some more stuff, right? So again, I'm going to go ahead and just round that to 2 decimal places. Notice the 7 is going to bump my 9 up. So what I'll end up with is approximately negative 234.30 if I round it 2 decimal places. Always check your specific problem on my math lab because it will tell you how to do it. Okay. All right. Let me show you one more using this formula. All of these we solved for F. On this one, it's going to be a little bit different. It says a 2,400 pound car traveling uphill has a grade resistance of 288 pounds. What is the angle of the grade? So when it says what is the angle, that tells me that I'm solving for theta. The angle's the thing that I don't know. So I should be able to fill in the other one. My force is my grade resistance. Okay, that's 288 pounds. And that's going to be equal to the weight of my car, which is 2,400 times sine theta. Okay? And remember, we're solving, we're trying to get theta by itself. So the first thing I need to do is get rid of this 2400. And I can do that by just dividing it off. I'm going to divide both sides by 2400. Okay? And if you do that, you can leave it till the very end to do. I always like to check because sometimes it comes out to a nice decimal. Oh yeah, that's not too bad. 0.12. So 0.12 is equal to sine theta. And then again, remember we're solving for theta. So to get theta by itself, I need to get rid of sine. The way to undo a trig function is to use its inverse. So I'm going to take sine inverse of both sides. It's equal to sine inverse of sine theta. And the reason I'm taking that inverse is so that my sine and my sine inverse will cancel. Okay. So this gives me theta is equal to sine inverse of 0.12. And now that's something that I can easily do on my calculator. Okay. So I'm going to use my second function to get my sine inverse of 0.12, close your parentheses, and we end up with theta is equal to 6.8921, blah, 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 right? And I'm going to go ahead and, since this is, let's see, this is a an angle, right? I guess it really doesn't matter. I'm going to round it just to one decimal place. I don't remember what we were doing on the other page. So this means that theta is approximately 6.9 degrees. Okay. Not too bad, just solving for the unknown using this formula. So again, I will give you this formula when I want you to use it. You just need to know what F and W stand for, and you need to understand, your solving process based on what you're solving for. The other formula that you will see in this section is radar speed, which hopefully none of you have had an issue with. Hopefully none of you have gotten pulled over. Okay, radar speed looks like this right here. The radar speed is equal to the actual speed times cosine theta, where theta is the angle between the radar gun and the vehicle. Okay, so I'm going to go ahead and just label this. We're talking about theta is the angle between the radar gun and the vehicle. Okay, so this would be my theta. Okay, this is my right angle, right? So when you're driving along here and you have a cop sitting over here watching you, right? This is going to be the radar speed, right? This is what he catches, and the angle that you're going, this straight on, is your A, which is going to be your actual speed. Right? So this is our actual speed, and this is our radar speed. Okay. And so if we look at this, the way that we come up with this formula, this one's pretty quick, is notice the two things that I know. If I were to label this triangle in regards to this theta, this would be my opposite side, right? This would be my adjacent side, and this would be my hypotenuse, right? So what I'm dealing with is I know my adjacent side and I know my hypotenuse side. So if I know my adjacent and my hypotenuse, that's cosine, right? That means that cosine theta is equal to my adjacent over my hypotenuse. Or in this case, they're labeled as R over A. So I could say that cosine theta is equal to R over A. And then if we're talking about radar speed, we want R by itself. So to get R by itself, I can just multiply both sides by A, right? So if I multiply this by A, and I multiply this by A, I end up with A cosine theta is equal to R. So this is how we're getting that radar speed. Who knew there was so much math involved when you get a ticket, right? All right, so this is actually the formula that this formula up here is talking about. R is equal to A cosine theta. Okay? So I'm not going to go through some examples with this, but we'll use this one exactly the same way we did the force one. They'll either give you the r and the theta and you find the a, or they'll give you the a and the theta and you find the r, or they'll give you the r and the a and you find the theta, right? They'll give you two, you solve for the unknown. Okay. All right. The last thing that I want to show you, normally I give a quiz after this section just to make sure we're always thinking about our 30, 60, 90 triangle and our 45, 45, 90 triangle. So I want to give you just a second to pause this video and really quickly draw me those two triangles. Just because we never want to lose our ability to find those values. So label it with the angles and label the side lengths, and then when you're ready, unpause it and we'll go over it. Okay? Okay, so let's see how you did. I labeled, this is my 30. Sorry, I didn't draw a very pretty triangle. Whichever one is the smallest looking angle, you need to have labeled 30. When you drew this triangle, if this one looks smaller to you, then that's fine if you labeled that one 30. But you should have a 30 degree and a 60 degree. Your 90 is already given with the box. And opposite your smallest angle is your smallest side, right? So opposite the 30 is the 1. Opposite your biggest angle, which is 90, is your biggest hypotenuse, right, which is 2. And then the other length should be square root of 3. Now, if you can just remember 1 and 2, the smallest is 1, the largest is 2, then you can even use the Pythagorean theorem to find this other one if you forget, right? Same thing with a 45, 45, 90. Both of the sides opposite the 45 should be 1, and my hypotenuse here should be square root of 2. Okay? This is something that we want to be able to know like the back of our hand, right? So if that's something that you're struggling with, this is something you definitely want to put on a like a formula sheet or a note card as something that you definitely need to know and be able to pull out of your brain pretty quickly. Okay. All right. The last one is finding the equation of a line. Now we've done this in previous sections, but it's been a hot second, so I just want to refresh on it, and I want to show you how we can use our 30, 60, 90 and our 45, 45, 90 triangles to help us. So anytime it says find the equation of a line, okay, that means we want to end up with something like y equals mx plus b, okay? So if we want to end up with this, there's two things we need to know. We need to know our slope, and we need to know our y-intercept. Now, lucky for us, pretty much any angle we draw, if we draw it in standard form, the y-intercept should be 0, right? Because we always start at 0, 0 when we're drawing our terminal side. So let's go ahead and look at one. It says, find the equation of a line that makes a 30-degree angle with the x-axis. And then it says a 60 angle, a 225. So we're just going to do one at a time, okay? So a 30-degree angle with the x-axis. So we're something like this. This is 30, right? Now, so what we're looking for is the equation of this line right here, right? That creates that 30-degree triangle. So in order to find this, we need to know our y-intercept, which here, right, is going to be 0, 0, right? And we need to know our slope. And our slope is our rise over our run. So our rise is this side, right, which is the opposite side of a 30. Remember, opposite of 30 is 1, right? And then we need to know our run. So our run here is the adjacent side of the 30, or that would be opposite the 60, right? So that's going to be our square root of 3. So that's why it's so important to be able to know these side lengths, because now that we know that, we should be able to write our equation of the line, because we know our rise over run is 1 over the square root of 3. So we get y is equal to 1 over the square root of 3x plus 0, because that's my y-intercept, right? And then the only other thing I need to do is rationalize my denominator, and I'm actually not even going to worry about writing my y-intercept because it's 0. So I just get y is equal to, if I multiply this on top and bottom by square root of 3, I'll get square root of 3 over 3x. So this is the equation of the line that makes a 30-degree angle with the x-axis. Okay? So there was that. I would like you to do the same thing, but I want you to do it with a 60-degree angle and a 225-degree angle. So draw where it looks, you know, where that angle shows up, and then we can use its reference triangle to figure out the slope of that line. So go ahead and pause the video and see if you can find at least one of these. Hopefully you can do both of them, but if not, go ahead and unpause the video and we'll work through it. Okay. All right, so for a 60-degree angle, right, that's very similar to the 30. Looks something like this. Now we're looking for this line, right, that creates that 60-degree angle. This is my 60. So I'm going to go ahead and just label this triangle. Opposite the 60 is my square root of 3 side, and then I also need to know this side, right? This would be my 90. So opposite my 30 is 1. And because it happens to be in quadrant 1, I know that these are positive values, right? So again, we're looking for y equals mx plus b. My slope is my rise over my run. So rise is square root of 3 here, right? And my run is my distance down here, my adjacent side, which is 1. Okay? And then my y-intercept, right, is still 0 because we're in standard form here. My line crosses at the x and y-axis origin, right, where they cross. So I end up with y is equal to square root of 3 over 1x plus 0. And then if I just simplify that, because I don't need to leave this over 1, and I also don't need to write the 0. So this is what the equation of a line looks that goes through and creates a 60-degree angle to my x-axis. Okay. Let's look at 225. If I graph 225, right, that's going to be past 180 and not quite to 270. Right, that looks something like this, right, this angle. So again, we always draw our reference triangle back up to the x-axis. It's going to look something like this. So 225 is actually 45 degrees past 180. So this is a 45-degree triangle. Okay? And we're looking for the equation of this line that creates that 45-degree triangle. So I'm going to go ahead and label my sides and then make sure that I have the right values, positive or negative, based on the quadrant I'm in. Okay? So if you look at a 45, 45, 90 triangle, we know that both the adjacent and opposite sides are 1. So I should have a 1 here, and I should have a 1 here. I don't really care about the hypotenuse because I'm only going to be using this to figure out my slope. And slope, I need to know my rise, and I need to know my run, right? Now, because these are down in the third quadrant, I know that my x value has to be negative, right? Because I'm going to the left on my x-axis. And my y is going to be negative because I'm dropping below my x-axis. So again, we're looking for y equals mx plus b. To find our slope, we do our rise, which is -1, over our run, which is -1, right? So that means my slope is 1. And then my y-intercept, again, it crosses at the origin at 0. So this should give me y is equal to 1x plus 0. And then just simplifying, we don't have to write the 0. And actually, we don't even have to write the 1. This would just be y equals x. Okay. All right, so that is the end of section 2.3. You should now be able to complete that assignment on my math lab. If you have questions, just let me know.